Welcome to the IoT Unicorn podcast. This is Pete Bernard from Microsoft. We have a very special guest today. We're going to be talking about long-term technology trends in the IoT space. So let's get started. Today's recording of a conversation with Gerhard Loots, who runs IoT for Telstra in Australia. So we had a good conversation over Teams. It was nice early morning for him, late afternoon for me. And we talked about lots of interesting things. He has a fascinating background. He's from South Africa originally and now in Australia. We'll talk about that. We'll talk about 5G, of course, and IoT. Always a hot topic, especially when talking to a telco like Telstra. We'll also talk a little bit about sort of where things are heading in terms of mass data analysis of lots of sensors and how what he calls black screen analysis, where you're really looking for anomalous behavior as opposed to just monitoring all the data that's coming in. So that's kind of a fascinating look at how things are heading in terms of IoT and some of the technology there. So get comfortable and enjoy this conversation with Gerhard. So Gerhard, thanks for joining us. I know it's bright and early in Australia, and it's kind of late afternoon here and in beautiful Redmond, Washington. But I appreciate the time, and I know we actually saw each other, I think it was a couple of weeks ago now at the IoT Summit in Redmond. And I know travel these days is a little bit more complicated. So we are leveraging Teams technology to have this conversation, which is good, as are many Microsoft employees this week and next week. But cool, yeah. So thanks for joining us.
Oh, Pete, it's a great pleasure to be here, and also, yeah, I think we've also been testing the extremes of Teams over the last couple of weeks. But it's fantastic that we can have tools like this in times like this, and it just highlights the importance of digitalization and the effect it can have on your workforce.
Yeah, for sure. I mean, I actually typically spend my time around campus at Microsoft using a headset or my phone or doing all kinds of Teams collab, and so, we've been using it a lot internally, and it's, we're all getting some good practice on it moving forward. So let's talk a little about kind of your journey here before we get into the tech. We always like to talk about the people before we get into the tech. And give us a little background about how you got to this role at Telstra in Australia. And so you're not from Australia originally. I think you had mentioned you're from South Africa originally.
That's right. Yes.
Fantastic.
Yeah, it's a difficult. When I was looking at the topics that we were going to discuss today, I was like, it's really difficult to pinpoint when. Because
right.
I was going back to, was that in the days when I was trying to make the Walkman in the 80s work better, or is the journey start perhaps a bit later? When I was working as a cinema assistant during my university days and trying to figure out a better way how to count people. But I suppose, look, my background is I am South African. I studied law and network engineering as a background, and when I finished uni, I started a telco, like a very niche telco that focused on high-speed internet. And because we had the bandwidth on the high-speed internet, we branched out into security pretty quickly, as you do in South Africa.
Right.
And we leveraged AI at that stage for video analytics and also audio analytics, even for gunshot triangulation. So I suppose that would really be the start of the journey for me. We then immigrated to Australia in about 2013, and I dabbled a bit with smart home, so those were the early days of smart home, when companies like Smart Things and Mojo and so forth were just starting up. So I had quite a bit of interaction there, and I then went on to run a microphone company of all things, and we used IoT quite extensively to do quality control and to also manage output, and I suppose that's where the bug really bit it in a very defined manner, because I saw what we can do in terms of productivity and effectiveness if you actually measure things, So I suppose that's really the starting point. Before I joined Telstra was lots of little touch points and quite a couple of experiences with using it, but it really came into full force when I joined Telstra about 4 years ago.
Right. Okay, great. And you said you had a microphone company, so I assume that you have a good quality mic today.
It wasn't mine, unfortunately.
Oh, okay.
Yes, but it's an international company called Rode Microphones. So they're Australian-made, Australian-owned microphones. So fantastic brand to use. Yeah.
Good. Yeah, actually, you were mentioning kind of smart home, old school smart home. I was recalling my my uncle down in Long Beach, who's now in his 80s, had all these smart home experiments over the years. Every time I would visit him, he'd had another smart home. Even back in like the 80s, 70s, he had like X10 connected everything, and all these X10 systems, and like he could turn things on and off and everything. And it was pretty amazing. Back then, it was pretty primitive, but I think people had a real passion for it. So it's obviously come a long way.
Tremendously expensive too, right? At that stage,
all the modules and all the things that you had to do there. But yeah, no, it's certainly come a long way. I mean, I think, when we were at this IoT summit a couple of weeks ago, we heard from a lot of customers and Microsoft folks. I mean, it's amazing what people are trying to do these days with IoT, and especially with connectivity. I think that's kind of like the magic, this kind of secret sauce about like, how do you get these things connected and how do you get them connected anywhere and any time? And then, that really starts to open up the ability to drive some really amazing business outcomes. And I know Telstra has been involved in some interesting deployments around IoT. What's been sort of one of your kind of highlights, or more interesting, intriguing IoT projects that you guys have been involved with?
Look, the whole journey has actually been quite intriguing because, if you look at telcos across the globe, they all facing similar digitization challenges as all other more traditional industries. And even just transforming us from being a company that, a business unit that predominantly sells connectivity, to now being about 50-50 on connectivity and non-connectivity revenue has been a really, really interesting journey. We've invested quite heavily over the last 2-3 years to up our software skills. And today we are now starting to see some of the benefits of more advanced software tools, leveraging AI to get to different insights. I suppose the most interesting example of IoT deployment that I've seen recently has been that we've got a customer who they're a logistics company, and they've got about 150,000 metal crates in which they place all the e-commerce parcels and so forth. And these things just they're not visible, right? Because due to the nature of it, it's a $500-600 device. You can't put a traditional tracker onto it. And we've started to help them to track things using Bluetooth as opposed to more traditional LTE or other mechanisms.
Right.
But the interesting thing is really the correlation again between new IoT and old IoT. And so and what I mean with that term is that IoT is a new term, but it's actually a very old concept. If you go back to the 60s, even you would expect IoT to really have started when the US obviously put some birds in the air to track submarines, and that was solving a very expensive business problem. And you fast forward a bit to the 80s, and telematics starts coming out, and these days we use essentially the same type of technology to track cats and dogs. And but the correlation between the old and the new is that back in the middle 2000s, when we started playing with video analytics, one of the biggest problems that we picked up was that you can put more cameras up, but the human mind and eyes can really only concentrate on 4 cameras at a time. And at that stage, the concept of black screen monitoring came out, where you don't have people looking at a camera, but you use video analytics to determine when something goes wrong on that camera. So what the operators would look at would only be a black screen, and if something goes wrong, you then start popping up the exception as opposed to monitoring every single camera the whole time. And we've seen something similar now in some of the data sets. So if you think about 150,000 things that needs to be tracked, our modeling has suggested that it would deliver at least 10 million data points per day, which you simply can't manage in a traditional manner. You need to sort of go back into black screen monitoring, and leveraging AI, we've been able to now start predicting when things go wrong. So I think it's an interesting little twisting point for us to say, well, perhaps the future of asset tracking isn't a map, but a dark map, or a black map, if I can use the black screen monitoring analogy there. And we were able to put 1,000 trackers on and predict with almost an 80% accuracy where we believe the 150,000 crates are. So it takes us to a future where, to track 150,000 things, maybe you don't need 1,000 trackers, maybe you need 10,000 and a bit of AI to tell you where things are. So that was pretty interesting.
Yeah, I think it's you touched upon an interesting point. I mean, back in the good old days, it was sort of like whether you had a screen full of TV cameras that someone was looking at, or you had some very big assets that were being tracked. It was, really sort of an inverse of what we're talking about today, where you're having a very high density of a little bit of information at very high density, and then using all of that to sort of find patterns and anomalies in what's going on, and then taking action based on the anomalous behavior as opposed to the other stuff.
Because we're creating massive haystacks of data, right?
Right.
And we need to find those needle insights to make sense of the amount of data that we're generating, and we can't think in a linear pattern anymore, because it's the data is growing exponentially the whole time. So I think the only way to get through that in the longer term is going to be managing it by exception, as opposed to managing it in real time, if that makes sense.
Yeah, no, totally. I think that like you said, the human mind is just not capable of understanding all of that data, and so we're going to need more and more compute power to look at all that data for us and sort of tell us what we need to know. And that's kind of fascinating that's happening. I thought maybe you could talk a little bit about doing things out in Australia around agriculture or water systems and things. Is that another area that you guys have been involved with?
Yes, absolutely. Look, it's interesting. If you look at innovation requires friction to take place. If you look across the globe, where you take Israel, for example, is very strong in obviously in military and health and ag and water, for that matter. It has required friction for a focus on that part of innovation, right? And I think Australia is experiencing quite a bit of friction on climate change. We're probably one of the nations that's getting affected the most by it. The bushfires has been absolutely dreadful over the last couple of months. And that's been followed up with probably one of the rainiest seasons ever, where I live.
Wow.
So if you're not suffocating, you're drowning. And so that massive climate change plays havoc on all ecosystems. One of the challenges that we're working through with some of the water utilities at the moment is that because of all the ash from the bushfires, the ash goes into the water system, which stimulates algae growth. The algae growth removes the oxygen from the water, which ends up killing the fish, and the dead fish affects your water quality. So there's this massive chain reaction coming through because of climate change. We've been pretty much at the forefront of helping water utilities manage this resource a lot better. In Australia and across the globe, water utilities lose up to 20% of the water between the dam and the tap. So figuring out where exactly that's going missing is a challenge, But the other challenge with water, of course, is that it doesn't play nice with electricity. So it's harder to put sensors into a water network than what it is to put it into electricity network. But recent advances in communication technologies and just lower power usage sensors is now enabling us to do it. We've had some really interesting, unexpected data events. One of the most curious ones for me has been that if you think of water pressure is obviously bad for the pipe. If the pipe is too pressurized, then it obviously deteriorates quicker. But one of the the customer experience issues is that if the pressure is too low, then people get annoyed because their shower doesn't run strong enough, or or their irrigation system. And so you've got to find the right balance. And the curious side effect that we got when we started measuring pressure in the pipe system was that at sometimes the pressure is unnaturally high. And if you think of what is required to generate pressure, it's actually, you need a pump, right? And running a pump when you don't need that amount of pressure means that you're consuming electricity unnecessarily. So we're actually saving a bit of electricity now also by making sure that the pressure in the pipes aren't too high. So there's quite a bit of water work on the agricultural side. We're quite involved with the supply chain side of things. There's obviously an increased need across the globe for proof of origin in terms of livestock and also produce.
Right.
So being involved with that is important for us. And the curious thing also about agriculture and water is that if you remove the application layer, a lot of the sensors and underlying hardware equipment that you would use in water is actually exactly the same that you would use in agriculture, right? If you think of a dam level sensor, that would probably use some ultrasonic depth sensor. You would use exactly the same thing for to determine how full a grain silo is actually. So there's a lot of commonality between the two.
Yeah, no, I think it's fascinating. I mean, it's you talk about agriculture. I mean, it's probably a whole other topic. I was talking to someone the other day. I mean, agriculture has been innovating in terms of automation since like the invention of the cotton gin. I mean, it's been 100 years plus of innovation with agriculture and trying to automate things and get more data to do better with water flow and not watering too much and not watering too little. And so I think it's fascinating, especially when you talk about high density sensor networks and then looking for anomalies like too much pressure or too little pressure. That whole system must be quite a complex thing to design and deploy. How does that change, do you think, over time? I mean, obviously we've changed a lot in the last 100 years. We're going to get these high density networks going. I mean, do things change in the next kind of 5 years, 10 years? What are some of the break points, I think, that you're thinking about in terms of getting to the next level for these kind of IoT driven outcomes?
Yeah, I think sort of, the interesting pattern here is that how much software is just evolving. If we think of even Teams, let's take Teams, like this didn't really exist a couple of years ago, right? And
right.
The functionality of this as a blank canvas is tremendous, right? I mean, I was even sitting this morning trying to, I was just, while we were setting this call up, thinking about, well, when you're in an office space and you need to log that the light is out, historically you would think linearly about putting a microphone down somewhere in the office. And it struck me that you go, well, why wouldn't you just write an application on Teams? And that you can say, hey, hey Telstra, or hey, whatever you want to do, the light is out in my room. And I think the similar thing is what we're going to see in the industry is that there's a number of unknown blank canvases at the moment that will remove the need for hardware. And in the next 5 years, I think the blank canvases like Teams or Power BI or whichever tool set currently exists is going to change the way we think about it. Because ultimately, if you think about IoT as making a business better or a home functioning better, there's a very natural self-correlation component to it, where if it's too expensive, the problem doesn't get solved, right? So,
right.
So I think in the next 5 years, what we will see is the reusability of existing things a lot, and taking that a little bit further. And I think also when we assess where we are on this journey, it's very early days, right? I mean, we're all still trying to figure out exactly which tool do we use where, and we're making mistakes at the same time. But I think in 5 years' time, what we will see is a more general adoption of this. We're certainly seeing it in the number of connections that we're connecting at the moment. It's accelerating at a rapid pace. So that would definitely suggest that we'll see more things connected. But I think the shift that we will see is the reusability of existing connections, and the effect that will have on bringing down the price to solve the problem.
Yeah, it reminds me of some of the software development that's happened and evolved over the past, decades. I mean, back in the day, I used to work at Phoenix Technology, which is a BIOS company. We programmed in assembly language, and we put bits and registers and all that good stuff. And now everything's been abstracted, where there's like reuse of code. The code reuse now is amazing, and the kinds of things that you can put together and create. And I wonder, down the road, like almost like the reuse of different IoT deployments and different sensors, you'll be able to sort of build solutions on top of other pieces of IoT and, be even more abstracted, so that you don't have to start from scratch with each kind of deployment. I think that'll be interesting to see. I think that'll speed deployments and speed solutions, as well as people are thinking about how to reuse some of the stuff that they've already done, whether it's code or hardware or whatever, and even more general purpose sensors, environmental sensors that can be multi-purpose or can be software controlled or programmed to look for other pieces of data, or maybe just a stream of data about lots of environmental things that then could be sort of disambiguated in the cloud. I think you're right. I think the reuse thing is kind of interesting, and certainly the tools that we have today, like you said, with Teams or these other things, it is a blank canvas. Like, we see customers that are deploying IoT solutions for a very specific reason, and then it's sort of like then the imagination starts to say, oh, well, can I also solve this problem and this adjacent problem and then this adjacent problem, and then it creates like friction, I guess you would say, to innovate even more to solve that next adjacent issue, right? So it seems like we're sort of on that road, for the next long period of time, I guess hopefully the next decades.
Yeah, well, I just think it's natural, right? I mean, if we go back to the first industrial revolution, where people started using steam and pistons to not have to carry water around, to start pumping water out of mines, we're still using that piston today, right? I mean, there's no real difference in the engineering behind the piston. And I think we build on top of each other. I was even, when you were talking about assembler, I was going, yes, I looked at that when I was 16 and I went, geez, like those guys were clever, and because I started coding on Pascal, and
sure.
Pascal was already built on assembler, and then you fast forward to Delphi, and Delphi is a bit more elegant, and then Ruby on Rails is even more elegant. And I was fascinated the other day, one of our really smart AI guys, I was just sitting there and we were playing around with a camera, and we asked him whether he can count how many people are crossing the pedestrian crossing on a red light, and he did it in 20 minutes. Wow. And having done that before, in 10 years ago in South Africa with video analytics, that was a couple of months previously.
Yeah, I was going to say that's a multi-month project years ago. And now you can go up to Azure and get some sample code and some sample solutions, and drag and drop and click a few things, and now you've got a pretty smart AI solution.
No, absolutely. So I always say to my guys, because we're starting to get a bit older, I'm telling them that our biggest skill we can work on is probably just our personality at this stage, because it's definitely accelerating. People skills, exactly.
Yeah, my daughter's actually coding in Python. She's taking a class in high school. She's 15, and there's all these tools and all these libraries and all these functions that she can use, to build stuff. Pretty advanced stuff pretty quickly. So I think that'll be interesting to see as like certain companies start to deploy things. They'll be able to reuse that infrastructure and that code and those platforms and do more and more things. So I think that's definitely a big trend. You've been listening to part 1 of my conversation with Gerhard Loots, who runs IoT for Telstra. In part 2, we'll be talking about autonomous systems, robots, and 5G. Stay tuned.